Hi everybody. The farther you go in programming, the more you're going to come to realize that the debugger is one of the most useful friends you can have. This is just a short demonstration of how the Visual Studio debugger works. So let's suppose I've got this short program that asks the user for a string and then prints that string one character per line. Here's my program. When I run it, if I type in Waldo, I get this for the output. The problem is I've got an extra blank line after printing the O. Now you might quickly guess what the cause is, but I'm going to use this small logic error to illustrate some of the debugger's capabilities. The big three for any debugger are these. First, the debugger will let you set a breakpoint, which is just a place where you want your program to wait so that you can examine what's going on. It's like hitting pause when you're watching a video. The breakpoint will show up as a red dot in the left margin of the program. You can set as many breakpoints as you want when you're debugging, but usually all it's going to take is one or two. The next major capability of a debugger is that it's going to let you step through your program one line at a time. This lets you run your program as slowly as you need to see what's going on behind the scenes. In other words, a line of code waits for you to tell it when to execute. We'll look at stepping through code more closely in just a minute. Finally, a debugger will let you look inside a variable's contents. Instead of just hoping, or worse, guessing what a variable should contain at some point, you can actually look. You'll see how this works as we go through a short demo of debugging a program. Are you ready? Okay, here's my program in Visual Studio. First, I've got to decide where to set a breakpoint. Sometimes this is easy because you figure out the area of your code that's causing the logic errors. But sometimes this gets hard because you have no clue why something isn't working, which means you have to set the breakpoint toward the beginning of your code. That's just going to take some practice to get used to. Here I know that the input on line 14 is working. In other words, it's reading the string correctly, and I know that the loop sort of works, but there's an error in that loop someplace. So I'll set the breakpoint on line 17 where the loop heading is. To do that, I'll click in the left margin. The red dot shows where the breakpoint is. Next, I'll press the F5 key. That will put Visual Studio into debug mode and will run the program to line 17, and that's where it's going to pause and let me type in a string. I'll type in Waldo and hit enter. Now the program screen is showing again, except now the breakpoint red dot contains a small yellow arrow. That arrow indicates the next line of code that will execute. Make sure you realize that where the yellow arrow is pointing here at line 17 has not happened yet. It's next in line to execute. That's a real important point. Now look at the bottom of the screen. There should be a window called Autos, and it contains information about two variables, str and x. Those variables were automatically placed in that window because they are nearby the place where the breakpoint was set. Visual Studio thinks you might be interested in them. When you set a watch on a variable, you're telling the debugger to let you watch that variable's values as your program executes. Thus, the Autos window has two watches, one for str and one for x. The watch set on str tells you it's an array of 40 characters and that it contains these characters. Just seeing the characters contained in the string might let you see the problem, but we'll keep going. The number to the left is the address of str. That is where it's located in RAM. That address looks weird because it's in hexadecimal, otherwise known as base 16. For our purposes, the address is not important. The watch set on X reveals that it's an int, no great surprise, and that it currently contains a junk value of negative 858 million or so. That's because our program hasn't stored anything in X yet. All that is fixing to change. To begin stepping through the program one line at a time, press F10. The yellow arrow moves to line 19, which will be the next line of code to execute. Remember, line 19 hasn't happened yet. Look at the autos window and notice what changed and what didn't. STR hasn't changed, and it won't, because our program never tries to change it after the input on line 14. CH shows that it has a junk value of -52, which is its ASCII character code. Here are the ASCII character codes for just the alphabet letters. X is now 0 because the for loop has stored 0 into X, and strx is W because the 0th character in str is W. Let's press F10 again. And we see that the yellow arrow has moved to line 20, so the printf will happen on the next step. We also see that the only change in the watch window is that character CH now has the value W because of what happened on line 19. Press F10 again, and the printf gives us this output so far. In other words, it printed the first character in the string. Let's go back to the program. The yellow arrow has reached line 21, which is the end of the loop. So when I press F10 again, the arrow goes to the top of the loop on line 17. Now think with me here. The loop first stored 0 into X, then it checked to make sure that the value in X was less than the length of the string str. Then it executed the body of the loop, and then the next thing that happens will be to update X by adding 1 to it. And that's exactly what happens when I press F10 again. Now X contains 1, and we go through the whole loop a few more times until X reaches 5 when we're on line 19. Notice that strx is the \n character, which will send us to a new line in the printf. That's the character that's causing us the problems of having an extra blank line. So I see at that point I forgot to remove the \n by replacing it with a terminating 0, like this. Which also means I can stop the debugger and fix my code. Now to stop the debugger, I can do it one of two ways. Either I can click the stop icon, or I can press Shift F5. Here's a couple more things. I can hover the mouse pointer over a variable and see its contents no matter where that variable appears in the code. And if I want to, I can pin that little mini watch and it'll change as the program runs. This can come in handy, just another feature of the Visual Studio Debugger. So let me end the debugger, and then I'm going to restart it. Notice the pinned watches are still there, and they show the junk values that were originally in the variables. As I step through the loop, they change along with the watches set down in the Autos window. The Visual Studio Debugger offers you a ton of features. This video covers only enough to make you more dangerous than you already were. But until you get into object-oriented programming and beyond, these few features will solve most of your logic error problems. Thank you for watching.